Welcome, ladies and gentlemen, to some integrated Math 2. In today's episode, we will be discussing Chapter 8.4.2, which is arcs and sectors. Before we get started with the lesson, I do want to do a quick little warm-up here. And the interpretation of the answer is going to be really important, because the area and the circumference of this circle is not really that hard to find. We know that the area of a circle is found using the formula pi r squared. In this case, the radius is 4, so that's not really that hard of a stretch. We would do pi times 4 squared, giving us 16 pi. No problem, no problem. The circumference is like the perimeter of the circle, right? So that's going to be all of the outside piece. And so that formula is 2 pi times r, or sometimes call it pi times the diameter. Because we're given radius, I'll go and just double the radius in my 2 pi r formula. So that becomes 2 pi times 4, so that's 8 pi. Again, nothing terribly difficult about the procedure of this problem, but realistically, I want to discuss the interpretation of the problem so that we can find out what this whole arcs and sectors is really talking about. So let's talk about area for a second. This idea of 16 pi, what is it? Well, 16 pi is basically talking about the area that's inside the circle. So if this was like a piece of paper, the area would be all the, stuff inside that piece of paper. Or if this was like a circular pool, this would be the surface level of water that takes place inside that pool right there. So all this blue stuff here is worth the 16 pi. So why is that important? Well, it's because when I'm finding the area, what I'm doing is I'm finding the area of the whole circle, right? So let's just go and write that down in our notes here. This is the area of the whole circle. Okay? In other words, when I say whole circle, I mean 100% of the circle. Obviously, right? Like putting ice cream in the freezer, we're going to find the area of the whole thing. Yeah, I mean, that makes sense, right? Same thing can be said about circumference. If I take the circumference, what I'm doing, I'll go ahead and highlight this in ketchup actually. If I do the circumference, it's the circumference, this 8 pi that I found, this 8 pi is the circumference of the whole circle, right? Just like the area was the area of the whole circle. So why would the circumference be any different than that? This is the circumference or perimeter of the whole circle. And when I say whole circle, again, like last time, I mean 100% of the circle. So again, procedurally, it's not that hard, but realistically, the representation of it, we really need to understand that when we're finding the area, we're finding 100% of the area, or 100% of the circumference or perimeter. And that was, generally speaking, pretty easy, except now I'm going to ask us to find an arc value and a sector value. Let's talk about what those things actually are before we even talk about how to find them. An arc is defined as a portion of the circumference of the circle. Okay, so we're not going to find all of the circumference anymore. We're going to find a portion of it. And then a sector, well, it wouldn't be that hard to figure out. A sector is going to be a portion of the area of the circle. Oops. So that's ultimately what this chapter boils down to, is how do we find a portion of the area of the circle? How do we find a portion of the circumference of a circle? Well, let's find out. I'm going to break it down into something really easy, and then we'll talk about how it was actually found. So what I'm going to do is I'm going to draw another circle here. I'll keep it the same. I'll make it radius 4. Now, instead of finding all of the area, and we know that the area is equal to pi r squared, so pi times 4 squared. Instead of finding all of the area, I'm going to ask us to find only half the area. Well, that just means that I would take this and call it 16 pi, and I would either divide it by 2, or I could look at it as multiplying the area by 1/2. Because again, I just want half the area. Well, that becomes 8 pi, right? Cool. Now again, if I wanted to find half the circumference, again, that's going to be 2 pi r, and that's going to end up becoming 8 pi. But again, if I only wanted half the circumference, I would take this 8 pi and I'd multiply them by 1/2, giving me 4 pi. Okay, so now, let's do this again with 1/4 of it. So again, if I wanted to now, again, I'll just go and draw the circle. If I want to draw a circle here, I'll go ahead and do this, and like this. So this is going to be here. So from here, I'm going to go and find just 1/4 of the circle here. Again, the radius is going to be 4. The area, unimaginably, is going to be pi times 4 squared. But again, I'm going to go and multiply it by 1/4 this time, because that's 1/4 of the circle, right? So that's going to be 16 pi over 4, which is going to be 4 pi. And then again, circumference is going to be 2 pi times 4, but again, I want 1/4 of it, so those guys can actually cancel each other out, giving me 2 pi. So nothing really that hard until we start to figure out what happens if I want now, the hardest version of this problem is going to be if I want now, I'm going to give myself an angle here, something that I can't really figure out that well. I'm going to go and call this 30 degrees. And I'll call this a radius of 4. So how do I do that? If I wanted to find just this portion here, if I wanted to find just this portion of area, how do I do that when it's not something that's easily divided? It's not like it's 1/4 or 1/2 or even 1/8 of something. I can't really do it. With the 30-degree angle, how do I find out the area and circumference of this? Well, let's take a look at how we figured out all of these. From here, half of the circle, right? If we look at half of the circle, well, if we look at a circle in terms of its angular measure, the entire degrees that make up the circle is 360 degrees of a circle, right? But in the case of the half example, we wanted half of that 360, which is going to be this space up here. Well, what's half of 360? Well, it's 180. And then times 16 pi. Well, in case you haven't noticed by now, 180 divided by 360 is reducible into 1/2. Interesting. So from here, if we look at the 1/4 example, well, it's not that much of a coincidence to find out that 1/4 would create a 90-degree angle. In other words, I am taking 90 degrees of the 360 degrees of the area. Now, it just so happens that 90 over 360 will then simplify into 1/4. So by that extension, if I wanted to find only 30 degrees of this sector area, then I would say the area is going to be that angle, just like I did with the 90, just like I did with the 180. I would do instead this time 30, and that's actually a horrible 0, 30 over 360, and I would do times pi r squared. So what does that equal? Well, the zeros are going to cancel. That's going to give me 1/12 pi times 16. So I believe 4 goes into both of those guys, so 4 and 3, so I end up getting 4 pi over 3. How do we find circumference? Well, it's the same thing, right? I mean, it's just going to be perimeter. It's going to be a perimeter, except except nothing. It's going to be a perimeter, and that's the only exception. So again, I'm going 30 degrees over 360 degrees. In other words, I'm taking 30 degrees of my total times 2 pi r. So what I have here again is 1/12 times 8 pi. Those guys will cancel, giving me, looks like they both divide into 4, so that's going to be 2 pi over 3. So in general, the generalization of this, in fact, before we do a generalization, let's go ahead and do another example real quick. So if I wanted to do another circle, and let's say I wanted to use something that looked kind of like this. Let's call this dude here a 54-degree angle. And let's go and do let's do a different radius this time. Let's do a radius of 5. So from here, if I wanted to find the area, let's say if I wanted to find the area of this inside piece here, then it would be 54 degrees taken of my 360 degrees, and then I'd multiply that by pi r squared. This one's not going to come out to be very pretty. So from here, 54, I believe that divides into 18, giving me 3. 360 divides into 18, giving me 20. So what I have is 3 over 20 times pi times 25. Now I believe the 5 and the 25 and the 20 can kind of cancel each other, giving me a 5 and a 4 up here. 3 times 5 is 15 pi over 4. That is the area of that sector right there. Let's get that in our notes, that way we don't forget. This is the area of the sector. And again, what is the sector? A sector is a portion of the area of the circle. A portion of the area. So, here comes circumference. So C equals, because I already know 54 over 360 simplifies, I can actually just call him preemptively 3 over 20 times 2 pi r, which is times 5. So now from here, I will go ahead and call this 3 over 20 times 10 pi. Those guys will cancel, giving me 3 pi over 2. And again, that is my arc length based on that angle right there. Remember, an arc length is a portion of the circumference of the circle. So at this point, I'm hoping I can clear the board and come up with a generality for how to find areas of sectors and arcs of circumferences. Now that I've cleared the board, let's go ahead and figure out a general formula for how we find out the area of a sector and the arc length. So the area of a sector, well, the way we did it was always like, when we had a circle, we always had like some angle, and it didn't matter what that angle was. So with that in mind, I'll give the angle a generic name, and it's something you guys know very well. It's this Greek letter theta. And whenever we did this, what we did was we took that angle, and it was the fraction of that angle over 360, which was the total angles of a circle, and then we multiplied it by the area of said circle. So in fact, let's write this down. Let's define these pieces. This is our angle portion. Angle portion right here. The 360 is the total angles of a circle. And then this dude here, the pi r squared, well, that's the area of the circle. So there it is. It's theta over 360 times pi r squared. That's your area of a sector. And then your arc length will be the same thing, where it's going to be the same theta, right? So again, your same angle portion over 360, which is your total angles of a circle, but instead of multiplying it by the area formula this time, you'll multiply it by the circumference formula this time, which is going to be 2 pi r. So keep those formulas in mind when we do areas of sectors and arc lengths, because when we talk about this girls' ice hockey team from our textbook, it will play a role. Right now it says the girls' ice hockey team goes out for pizza. The goalie eats half the pizza that has a diameter of 20 inches. What is the area of the pizza that she ate? And what is the length of the crust that she ate? Well, in A, well, here's the thing, is that if the diameter is 20 inches, I'm hoping that we can conclude that the radius is 10 inches. I hope we can figure that out. Well, if she ate half the pizza, well, half the pizza is how many degrees of an entire circle? Well, we just did a problem like that, right? It looks like this goalie ate 180 degrees of the 360 degrees that were originally there. And that's going to be times pi r squared. And again, we're just finding out the area of pizza that she ate. So that's going to be 1/2 pi times 100 if I square the 10. And that's going to be 50 pi, looks like inches squared of pizza consumed by this goalie. And then the length of the crust that she ate, well, the crust is the perimeter of the pizza, right? And hopefully it's thin crust because Chicago deep dish is nasty. So from here, the circumference is going to be, again, she ate half of the crust. So that's going to be 180 over 360. Again, 180 degrees eaten of the 360 degrees. But this time it's going to be multiplied by 2 pi times r, which is 10. So that's going to be 1/2 times 20 pi, which is going to be 10 pi. And this time it's just going to be inches, because we're not talking about area anymore. We're talking about circumference, which is perimeter. Hopefully A made sense. Okay. And so from here, B, it says Sonia chooses a slice from another pizza that has a diameter of 16 inches. And then if the slice has a central angle of 45, what was the length of her crust? And show how you calculated the answers. Okay, so here comes Sonia. Sonya Blade from Mortal Kombat. 16 inches. So from here, if the diameter was 16 inches, I hope we can understand that that means that the radius is 8. And if the central angle is 45 degrees, then we have to find out what is the area of her slice and what is the length of the crust. Okay, well here we are again. The area of the slice, 45 degrees is being taken of the 360 times pi 8 squared. 45 over 360 busts down into 1/8 times pi 8 squared. The squared and the 8 will cancel, giving me 8 pi. And then the circumference of that is going to be, again, 1/8 times pi, oopsie, we're not doing area again, we're doing circumference. So times 2 pi r, which is 8, so the 8s can cancel. She ends up with just 2 pi length of circumference. I should call this inches, and I apologize, I should call this inches squared. Okay. So it says, as the evening draws to a close, Sonia notices, we're on C, Sonia notices that there is only one slice of the goalie's pizza remaining. She estimates the central angle to be 72 degrees. Using this estimate, what is the area of the remaining slice? What is the length of the crust? Okay, this is old hat at this point. If what's remaining of the pizza is 72 degrees, that means that the area is going to, I'm sorry, it was the goalie's pizza, right? Okay, if it's the goalie's pizza, sorry, I had to reference that again because the goalie's pizza is a 20-inch diameter, making the radius 10. I just had to reference that one more time. So from here, that means 72 out of the 360 is going to be multiplied by pi times 10 squared. So what that becomes is it becomes 1/5 times 100 pi. 100 divided by 5 is 20, so 20 pi for the area. Just keep doing A. The circumference of that is going to be 1/5 times 2 pi r. So those guys cancel, giving me 2, so I end up with 4 pi as my crust length. So again, this is inches, and this is inches squared. At this point, I'm hoping that people are starting to understand the tempo of this. Go ahead and pause it if you need to. Let's see here. Okay, so now D and E are simply math-related questions, no longer relating to pizza. And so from here, let's see here. Okay, they're defining what an arc is. This is the set of connected points from a fixed center point. The length of an arc is the part of the circle's circumference, a portion as we called it. If the circle has a radius of 6, what is the arc length when a central angle is 30 degrees? Okay, we already did kind of problem like this for D. So again, if the radius is 6 and we're creating a 30-degree angle, that means that the circumference is going to be 30 of the 360 degrees being taken times 2 pi r. So that's going to be 1/12 times 12 pi. We get pi. And then E, a region that resembles a slice of pizza, is known as a sector. So again, that's the area, right? Bounded by 2 radii of a central angle and connected to the endpoints on the circle. If a circle has a radius of 10 feet, what is the area of a sector with an angle of 20 degrees? Okay, so here's our circle, angle 20 degrees right here. That means that we're taking 20 degrees of the 360 degrees. And from here, since the radius is 10, I'm going to do pi r squared, 10 squared. So this is going to cancel. I get 1/18 times 100 pi. And I believe they both divide into 2. So I'm going to get 50 pi over 9. And that's going to be feet squared in units. So again, I hope you guys got a little bit out of that sectors and arcs lesson. As always, go ahead and leave any comments or questions into the comments area, and we will answer them when we get back in class, and I will see you in the next episode.